As your jaw moves from side to side, the alignment of the teeth should generate separation of the back teeth. If this doesn't happen, then the teeth start to wear down and the back teeth can come into contact. As they come into contact, they move and get loose in their socket, infection can get in, and parts of the teeth enamel can actually break off the side of the teeth. Back teeth that sort of rub together stimulate the sensors in the teeth to fire the nerve. Overstimulation of the nerves makes the teeth very sensitive to hot and cold, can even be quite painful. As the teeth move across the surface of each other, the enamel just slowly and eventually erodes away. The cusps disappear and the teeth get flat, which makes them more inefficient in the way they work. You need to use more muscle energy to make them work. They actually put pressures on the side of the teeth, and the back teeth start to move around, and you get bone loss at the side, allowing infections to get in down the side and can eventually lead to the loss of the tooth. And of course, the forces actually create cracks in the enamel, micro cracks in the enamel that can generate bigger cracks, and eventually the teeth break apart. As the teeth rub together, they also trigger the nerves to fire the muscles. The muscles try and move the teeth around into a position where they're not damaging each other, and ultimately result in overstimulation of the muscles and can generate pain. Traditionally, dentists use marking paper, dental marking paper, to measure the forces on the teeth. Unfortunately, this really isn't very accurate. It simply shows where the teeth have come into contact, and it doesn't show the amount of force on the teeth, nor does it show the timing of the force on the teeth. It's very inconsistent, and there really is no evidence to support its use as a scientific and consistently reproducible method of adjusting teeth. The biofeedback mechanism in the brain is very, very sensitive. Teeth have highly sensitive pressure sensors within them. They feed back in nanoseconds, and this timing is critically important for triggering the muscle activity. A bite balance analysis involves simply biting down on a sensor held in an instrument called a T-scan. Patient just bites up and down on the sensor, and the sensor can very accurately show the forces, the timing, and allow the patient, the dentist, to make very accurate adjustments. This is the data that comes from the T-scan. As the patient bites onto the sensor, the dentist can see how the forces develop as the teeth come together. So you can see the forces developing relative to each other, and also as the patient makes a move to the side, then we can see how the forces transmit, and we can see how the back, in this case, how the back teeth here are still in contact, and the sensor also measures timing. So this particular patient's teeth come together in 0.531 seconds, and they separate in 2.482 seconds. So a long time for both. T-scan screening measures the forces and the timing on the teeth. It gives an indication of the risk of damage and also an indication of the cause of any pain. It's highly reproducible and measurable.